Thanks for joining me for today's workshop, Low-Code Data Visualization for the Web with New York City Open Data. About 8 years ago, I started my coding journey because there were visuals I could imagine, but I didn't know how to make them. I felt like my tools weren't letting me get close enough to the graphs that were in my head. And today, I want to help you to be able to close that gap without necessarily having to learn to code as well. So for those I haven't met yet, my name is Cameron. I work at Datadog, making visualizations that help people keep their computers healthy. Before that, I studied electrical engineering and computer science, and I worked with a variety of public data sets in the spaces of healthcare and the environment. Outside of work, I co-organize a database meetup with Naomi Robbins, and I contribute to open source visualization libraries like Vega. I thought I would just show some of the visualizations that are possible with code. So at one point, I took the Metro North every day, and I had to look at this timetable to figure out when to take the train. And it's a lot of numbers. You can't even really see them that well right now. So I adapted a historical visualization for looking at a train schedule from Edward Tufte's book and made it interactive. And it helped me give a sense of when the busy times at the train station were. I also like using data to make art for people. So when I've had interns on my team, we sometimes make thank you notes using data generated by their activity on our team. But before we go into the specific tools on our tour, I want to illuminate why increasing access is so important to me when we talk about data visualization. When I first learned about and started using graphs in school, it felt like a thing that I did at the very end, only when I had solved the problem. And it wasn't really part of the thinking process. And I began to change my mind through an experience where about a month of work was thrown away, all because of a graph. I was in a lab where we were studying ADHD and brains. And the goal was, given a brain scan and an ADHD behavioral test result, could you figure out what the brain of someone with ADHD looks like? Our data was shaped in terms of voxels. That means it's a cube where a value is changing over time. And we didn't realize until a month in that the data was unusable. Now, this is because to compare voxels, you need to take the shape of someone's brain and sort of stretch it so that it matches a canonical brain. And the problem was that we were using a stretching function suited for adults, applying it to kids' brains. And most people, including me, cannot picture this four-dimensional voxel space. So it wasn't until a lot of code had been written that we realized the data was unusable. I only really knew how to use Excel at the time, and I was just learning MATLAB. If I had some of the tools and techniques that we're going to see today, we might have been able to catch the bug sooner and save some of the research. So that's what augmenting cognition means to me. Visualization, when available, has the power to reveal details that would otherwise be hidden. So to illustrate this, there's a study that I thought was kind of fun with university students learning statistics, where they were asked to explore the correlation between steps and body mass index. And I'm especially interested in exploratory data analysis because of this paper. The research was split into two groups. One set of students was asked to investigate a particular hypothesis. The other group was just asked, can you find something interesting? Now, what the students didn't know is that there was something very funny hiding in the data set. There was a cartoon of a gorilla. But when people had a hypothesis in mind, only 1/3, only 1/4 of the people realized that a gorilla was present. And even when people were asked to be open-ended, 1/3 of the people didn't notice the gorilla. So this tells me that even with visualization, everyone has blind spots. So it's important that you have a lot of people looking at a data set so that hopefully collectively somebody notices when there's a gorilla hiding in your scatter plot. So now that we've warmed ourselves up on the idea of hiding big creatures in a scatter plot, let's look at another example. So here's a dinosaur. And how might we train a robot to notice dinosaurs hiding in your data set. This is a riff on Anscombe's quartet in statistics, if you've seen that before. And the question here is, do these summary statistics capture dinosaurness? Like, how different could a data set look if it also has these summary statistics? And it could actually look extremely different. You could have positive correlations, inverse correlations, other kinds of shapes like stars, even have stripes. I'll let you judge for yourself how different these new data sets seem, but the thrust here is that I'm not concerned about robots coming to take the job of finding interesting patterns in graph anytime soon. I still think this is a human specialty. So there's a saying in software that's used to motivate moving things into open source, and it's called Linus's Law. Given enough eyeballs, all bugs are shallow. What this means for us, I think, is that the more people have eyes on a problem, the more likely it is that someone will spot the dinosaur or the gorilla in your data set. So my goal is to get more eyes on New York City public data. New eyes can mean more people, or it can mean giving the same people new perspectives. And so today we're going to take a look at the low-code perspective. So enough about animals hiding in graphs. Let's talk about some real problems. Over the past few years, I've been looking at data sets with researchers and concerned citizens about problems ranging from climate change to drug overdoses to finding vaccine appointments. Imagine you had to solve these problems by writing emails and letters, and you had to play this word game. This is the slightly interactive part of the presentation. Can I get an adjective or a noun from the audience? Actually, I need both. And then we'll plug them into the game.
Enormous.
I heard enormous, and I need a noun, please. Person. Thank you. All right. So Mad Libs, you have a sentence. You fill in some blanks. There are enormous ways to choose a person to read, and you can proceed on your own time. But I want you to think about how limited you'd be in the number of problems you can solve if you had to solve everything. You had to ask for help from your coworker or place an order, explain a decision using Mad Libs. I think that Mad Libs are great time savers for retelling familiar stories. I find them limiting when I need to do something new. And I sometimes feel like making graphs in a no-code tool can feel like this when I have the option of writing full sentences. So if we come back to our question of why is it that low code and data visualization tools matter? I think data visualization tooling, accessible visualization tooling is important because it gives you new ways to think. But this low code part, I want to explain a little bit. So I think that if you have coding, you have total freedom from templates, but it comes at the expense of some strictness. You have one semicolon out of place and then nothing happens. Whereas a low-code tool to me is a tool where you can point and click, but the tool produces some code for you so that you get the productivity boost of a no-code experience, but you also get a code foundation that you or your teammates can build on later. So you don't have to trade between freedom and being able to get a useful result in a reasonable amount of time. So let's talk about how to get some more eyeballs on this New York City open data. Today's tour will be split into 4 parts. We're going to go through showing your train of thought, extending the slot-based Mad Libs model to a block-based model. We're going to look at some maps, and we'll talk a little bit about cleaning your data. And so I'm going to start with why I think showing your data journey is the first important piece of a low-code toolkit. So going into the low-code world oftentimes means you have to switch around between many different apps because there's not really a one-size-fits-all approach. Your multi-tool may have both a knife and a scissors, but they're not the replacement for a dedicated tool for the job. You're not going to use scissors to give, or your multi-tool scissors to give someone a haircut. You're not going to use the built-in knife to chop down a tree. You're going to want dedicated tools for those things. But you still need a way to be organized and not lose track of. So I'm going to show a couple different ways that I like to organize my analyses, low code or otherwise. I made a little tree using this built-in slideshow maker. This is something called a value driver tree. It was popularized by DuPont in the 1920s. And the basic idea is that you draw some values on the left, and then the drivers that affect those values on the right, and you extend your tree as far as you would like, based on your problem space. I'll show a more filled out example. Even though it's called a tree, it can actually be a network, which just means that some of your drivers can have more than one parent. So here we have the quantity. It can affect both sales and the cost. How do we connect this to data visualization? So once you have this tree backbone in place, when you make graphs, you can put them onto your values and your drivers. So here I have a little graph of expenses, and we can see that's going up over time, and you might ask why. So we can break it down into travel costs versus labor costs, and then break travel costs into travel to different places, and see that, well, all right, expenses were going up, but the flight price was going down. Even if we lowered the flight price by this amount, that may not change the total expenses meaningfully. So if we want to understand why expenses are going up, maybe we should explore a different branching spot in the tree. And you can adapt this to your own domain however you would like, but I find this value driver tree structure very, very helpful for orienting different tools. So how do you actually draw these? Or there's one more type of tool that I use sometimes, and it's called I call a drill down tree. And in this situation, I start with the full data set on the left, and then I document what are the different operations that I'm doing to that data. So say we have a full New York City open data set. You might split it into smaller groups, say by borough. And then after I split by space, I might also split by time. And you'll see more concrete examples of this very shortly. But what the benefit of this is that if I reach this point and I don't find anything interesting, I can backstep my train of thought and choose a different decision point to make a different decision and continue to document my analysis from there. So I mentioned how the first diagram was made inside a slide, and I think that's a great starting point. But a limitation I find with diagramming inside of a slide tool is that once I get to the edge of the page, I start shrinking the fonts or scrunching up my blocks, and sometimes that's not what the data analysis needs. It's just because I've run out of space. So I think it's really important to have an infinite canvas available when you're trying to do this type of analysis. We're going to show one tool for this called Excalibur, where whatever is the size of your analysis, you can just keep scrolling and the canvas makes space for it. Another benefit of this tool is that it has this hand-drawn look so that it discourages you from getting caught up in small details that don't matter that much yet when you're just doing exploration. And lastly, if you want to introduce some automation to your drawing tool, this is the low-code part. You or someone that you work with can help you speed up the drawing process. So I'm going to show you a quick demo. So here is the graph that the value driver tree that we saw earlier. I could take my blocks and start copying them and showing alternate paths if I would like. One other feature that I'll show is that if I have a small CSV or a table that may have arrived in an email or that I'm copy pasting from a spreadsheet, I can copy and paste new graphs directly into my canvas, and it'll have that same hand-drawn look that matches the rest of my value driver tree. The other nice thing that you can do inside Excalibur is that if your tree gets kind of messy, and mine certainly do, and they're not evenly spaced, you can write scripts that will organize the blocks for you. And this was a demo that I did last summer for something to organize rectangular blocks. Now, coming back to data viz, you might be thinking the sketchy graph is cute, but there are only 2 chart types. I could do that with an expo marker, and well, I could paste screenshots of graphs from my main tool, but those get out of date quickly. So FigJam is a free tool made by Figma, which is a popular design tool. This approach came up because I was using Figma as a UI design tool, and I couldn't make graphs in it at the time. And I had this wish to be able to organize my graph exploration process using the same infinite canvas that I was getting from Excalidraw. So I'm going to show you a small demo of the picture that was in the heading for this event. So here we have a zoomed in version of this graph, and my analysis here, it started with a scatter plot. I realized that my points were kind of scrunched up, so I removed the default axis settings so that I could see my distribution more evenly. Then I thought about maybe I would like to change the theme for the graph, so I explored a couple different options. And I used the branches to show the different variations so that I could show it to the designers or the product managers that I was working with. Then I realized that there was only one of these penguins that I was, or two of these penguin species that I was interested in. So I applied a filter. And then at the end, I ran a linear regression to look for a more structured pattern in the data set. I'm not explaining how I configure these graphs because that will come up later. I just want to warm us up to the idea that it's really nice to be able to look at different graphs and show the evolution of a thought process visually, as opposed to being pushed into a linear approach that might result if you had to do things inside of a notebook or a slideshow all of the time. And I can also use this commenting feature to add notes about specific parts of the graph. This may not be colorblind friendly, for example, and use this as a thinking tool and not just a presentation tool. So at the end, we're actually going to see an example of how Excalidraw can be put inside of FigJam, because sometimes there's a need to have that sketchy look in combination with the more sophisticated graphing capabilities that we have inside of FigJam. But let's not get ahead of ourselves. Now we're going to take a closer look at VegaLite. So moments ago, we talked about being free from sort of a Mad Libs graph approach, where in order to do anything, you have to fill in these pre-filled slots. VegaLite is a format that offers some of these slots, but once you've built a block with your filled in slots, you can start stacking those blocks on top of each other. I would compare VegaLite to SQL. SQL is a common language that people use to query data. But the important thing here is that SQL is not something that's specific to JavaScript or Python. Once you learn SQL well, you can query data across a whole bunch of different programming languages effectively. And what's more, there's a low-code ecosystem that has sprung up around VegaLite and SQL, meaning that if you use any of these different data analysis tools or public data tools, they're capable of accepting or producing VegaLite. You can reuse that everywhere else. And that to me is why it's really great to have a building block versus you learn slots for one tool and then you can't really reuse that knowledge anywhere else. VegaLite has a long history. It builds on the same set of research that Tableau and D3 and the grammar of graphics approach that's used in the R world. It's coming from the same line of thought. And there are two main ideas that I'd like you to take away today about VegaLite. First, VegaLite is a lot like Shrek. Shrek is an ogre. Ogres and onions and VegaLite all have layers. This is a metaphor used by everything from Photoshop to GIS software, where you take your different slices of interesting data and you stack them on top of each other, like physical transparencies. Another way to think about this is that you can take the color pictures coming from your printer and split them into the cyan, magenta, and yellow layers and stack them, and then you get a color picture. If we translate this back into the visualization world, you have a layer for your axes, you have a layer for your labels, you might have layers for your rectangles and your circles, and so on and so forth. You can stack them all together. Within each layer, you usually have to make a choice. You have some attributes in your data, and then you have a visual variable. And a association between a attribute in your data and a visual variable is called an encoding. Today, we'll mostly make use of position and color encodings, but there are many other ones that are also available. I actually have a scrolly teller, which will explain to you how to build up a Vega spec one line at a time by changing one line at a time, and we can see how we can gradually transform a colored bar plot into a dot plot. We won't go through this in full today, but I'll share a link to this afterwards. Today, we're going to be focusing more on a low-code approach to generating this same configuration language. So to set this up, there's one other important idea in Vega called faceting. And to me, faceting is about taking these layers, and instead of stacking them on top of each other, you put them next to each other. And usually each layer ends up being a different segment of your data. To do this, we'll use a tool called Sandance. Sandance is an open source tool made by Microsoft. And the core idea here is that every row of data is equivalent to 1 grain of sand in the UI. We'll be looking at the legally operating businesses dataset, which has 270,000 rows and many different columns. So let me enter the screen. So by default, it picked out some columns that it thought were interesting. It noticed longitude and latitude. And Brooklyn allegedly is very squished. So I'm going to click through and show how I might use faceting to slice this data into a more interesting picture. So I'm going to go to this facet operator. I'm going to slice by longitude, and note that there are some sections that I decided are really skewing the x-axis. So I'm just clicking, and we can see the grains of sand moving around. And now, when I remove my facets, we now see something that looks a little bit more like the outline of Brooklyn. Right now, I'm running this in the browser, but Sandance can be run locally inside VS Code or Power BI, actually. So Vega has chosen, or Sandance has chosen some colors for us. Let me start by leaving it blank. I am following through with what I said earlier about not being too hypothesis driven yet. Next thing I might like to do is to segment by color. So I know I have industry hiding in here, so I want to see if different industries have different clusters in terms of where they're represented. And if I just color everything by industry, things are kind of squished together. It's hard to actually see if there's a pattern. So I'm going to facet by color, facet by industry. And now I've reproduced that scatter plot that we were seeing originally, but each industry is in its own bucket, so I can be a little bit more focused. And if I want to focus on just one industry at a time, and notice that, say, garages are in the north, closer to Manhattan, whereas towards the south, the density is not so intense, I can do that. I can do things like, let me undo. I can change my color palette. If I don't like the default one, this one is probably fine though. You can choose to size by other variables if you would like. So here I might size by the license length. This wasn't very useful, but I just wanted to show that it was possible. And everything that I'm doing, Sandance is keeping track of the history log. So if you messed up or you want to undo some sort of transformation, you can rewind. Now, what does this have to do with Vega? Because so far I've just been pointing and clicking. If you go to this export button, you can see that our clicking actions have generated this big block of JSON, which you can copy paste to other tools which accept Vega definitions and use that to go through what we've been doing with pointing and clicking, but in a more programmatic fashion. And if you filter down to a subset of the data that you think is useful, so for example, let me go back to my history and say we were interested in the let's say this slice, and I chose to isolate by it, I can go to the dataset export option and export all the rows that I've picked out. So this was a quick look at Sandance. So for now, if you want to take that Vega definition that I shared and use it in another tool, you can send it to an app called the Vega Editor. I'm working on figuring out how to get this to work inside of FigJam. VegaLite is a simplified version of Vega, but that's still in progress. So there's one more Sandance example that I'll show that isn't so scatter plot oriented, and we'll take a look at a waffle chart. Here we go. So, sorry, switch tabs. So this is a different data set. It's the restaurant inspections. And here we have each of our restaurant inspections, and they've been colored by what sort of action was taken at each restaurant. I can make a bar chart instead of a scatter plot. I can make a tree map if I wanted to size things by score. This is a little different than I remembered it. So we might actually move past this example and come back to it at the end if there's more time. But yeah, so the other part of VegaLite that I think is worth bringing up is that data visualization is two parts, and I think the data half is worth talking about as well. And this refers to doing things like filtering your data or transforming your data. I find that when I'm in a visualization tool, and if I learn that I have to go somewhere else to bin or filter, sometimes I skip that data transformation step and just try to make do with what data set I've already loaded into the graphing tool. And that's not really what you want when you're doing data exploration. So to illustrate where this can help, we're going to take a quick look at New York City air quality data set. So it's in near real time. It updates almost every hour. And air quality, or the amount of pollution in the air at these 5 different sites, is being graphed on this public data portal. So I learned about this page. I learned that you can see this data on GitHub, and I decided to go and take a look at it. So let's change tabs. So this is what the data looks like. It's in what we refer to as wide format, where each new series is in its own column. There's one nice thing that you can do when you're inside of a GitHub on a CSV on GitHub, and that is if you add flat to the front of the address, you get this nice little data explorer where you can actually filter and look at your data in a more human readable way than a regular CSV. And you can actually look at different versions of the data. You can time travel to how it looked 8 hours ago or a day ago, because like I said, this is updating every single hour. Now, this is good. I was happy about this, but there's one problem if I wanted to be able to use this data set right away. And that is this wide format, which is good for humans for scanning across a table, is not so great for working with a lot of different charting libraries, which expect data in a long and tall format. The idea is that instead of having a new column every time you have a new sensor showing up, you need to rotate the data and create a borrow column and a value column so that when new sensors show up, you don't need to change the width of your table, because these scripting languages tend to prefer that the width of your data stays the same all of the time, and you can just make the table taller when you need to. So Vega actually, by default, could handle the wide format by letting you create a new layer every single time. So here I've taken one layer just for Queens College, and it's blue by default. And I have this second layer, which I've made red for the second site. And I would have to repeat copy pasting this block for each one of those 5 places. Just to show you that this is running still. I'm just gonna run it. Yeah, so this could take a while. if you have a lot of sensors to work with. So we solve this problem in Vega by allowing you to transform the shape of your data from directly within the JSON definition. So here, I use this operation called a fold, and I list out all the columns that I want to transform using that wide to long operation that I mentioned earlier. And with that, I'm able to just write fold once, so it reshapes the data internally, and then I only ever have to create one line mark, and from that point forward, we'll be all set, even as new sensors get added. There are 18 other data cleaning operators that we're not going to go into today, but they're available if you decide to continue this VegaLite journey. So I like VegaLite a lot. It's really powerful, but there are limits. Just because you've graphed latitude and longitude in a scatter plot does not mean you have a usable map. So when I need to map, I go to some other low coding tools. This brings us to Kepler. If I need to do a geospatial data analysis in a way that I can share and work with and can publish to the web, I like to use Kepler. It has plugins in Jupyter and Tableau and a lot of other tools, but we're going to be looking at the web-based version of it. So to do this, we will be looking at business licenses and analyzing them across both time and space. It's the same business license data set that we looked at earlier on in Sandance. So go into full screen. So here we have our familiar looking scatter plot from before, but now we have a base map. So if you didn't happen to have the shape of Brooklyn memorized, this will help you orient yourself. So what are some of the things that we can do here that we couldn't do inside of Vega? So one, you have a tooltip. So when you mouse over different points, you can see details about each data set. And if you go into this interaction panel, you can change which fields exactly show up. So I think that, say, for example, the business name is a useful thing to know. And I have comparison mode turned on as well. So if I wanted to look at two different businesses and say, which one of these has been around for longer and by how much, I can click on a business and, oh, I have to add one more here. I'm going to calculate the license length. And then if I mouse over any nearby points, it has color coded and marked how much older that particular business is compared to my original reference point. Some other nice interaction details that are in Kepler. You have a geocoder. So if you need to look for a specific location, let's say Dumbo, you can look that up on the map and then it'll pin it for you. If you are trying to do something like you have some significant point and you want to know what sorts of places might be walkable within 5 minutes, you might turn on your brush and then highlight only the points that are in a certain radius of where your pointer is. And yeah, so these are the main interactions that I want to call out. I won't spend too much time on the basic mapping capabilities here because many of these overlap with what you could do inside the built-in Socrata mapping portal, in that you could change what column attribute you've bound to the color or the size of each one of the points. But one very unique Kepler, I think, is the Kepler ability is the ability to filter and play back things over time. So by this, I need to select a column. I'm going to select expiration date. And so, actually, no, I'm going to add creation date. And you can see when these different businesses were introduced to the borough over time. Sorry, I have two filters on at the same time. Fix this. Yeah, so now if I click play, you can kind of watch the different businesses sprinkle onto the map over time. And you can either have a sliding window if you're interested in like only looking at a year at a time, or you could change to a incremental time window where the start time stays fixed, but the end time is moving along and you can look for patterns this way. To wrap up this part of the demo, I'm going to color the graphs by industry, because I know that there's a lot of values for this. I'm going to change the color ramp to 20 so that we don't get repeats. And we can watch and see if things get more interesting if we look at expiration date. Move this filter. And I thought it was neat to see that over the course of the next year that only some types of industry were having their licenses expire, but there was this massive jump of pink starting in 2023, which was home improvement contractors. And I don't know that if this would have jumped at me if I were just working within a spreadsheet at the time. Yeah, so one other nice thing you can do inside of Kepler besides graphing individual points is comparing a sort of a density-based analysis with a point-based analysis. And what I mean by this, to illustrate this, I'm going to layer in another location-based data set. So I have something called the privately owned public spaces data set, which is places where you can go to find outdoor seating. And you might want to find what are some places where there's a lot of outdoor seating and restaurants that have gotten grade A on their inspections. So I'm going to take this new data set that I just added, the public spaces, pops, and instead of drawing points, I'm going to change this to hexagons. So now I have my hexagons, and I want my points to go on top of them. So I'm going to take my points and put it higher up in the layer stack. So now they show up on top. And I'm going to remove the color attribute to something with a smaller number of color ramps so that they're easier to see. And then I can look for patches where there's a high amount of pop locations and also restaurants to decide where to be visiting. Cool. So this was a lot of talking about maps, but I also told you that we would get to look at trees. So we're going to do that now. And for this, I like to use something called raw graphs. Raw graphs is an open source tool that's been around since about 2013. Every single visualization type in it has a demo video if you prefer to get instructions that way. And I would describe it as a collection of D3 visualizations with a form attached so that someone can configure the visualization without coding. There's actually 29 different types of graphs inside of raw graphs. I suspect many people may have seen this before, but we're going to focus on the tree part because this is something that I really like Vega, but I don't think Vega is the best place to be exploring tree-shaped visualizations yet. So I'll go through one of these examples, these tree examples using Vega. And for this, I've downloaded the New York City payroll dataset. I didn't really want to single out any individual salaries because I don't think this is the right way to go about it. But I thought it might be okay to look at things by department. So first I loaded my data set from a local CSV. Then I select the linear dendrogram type, which is another way to say a tree visualization. And then you have a set of columns on the left, which you can drag and drop to different visual variables on the right. So I'm going to, for example, take the pay basis, followed by the agency. I can see my tree is slowly being filled out down here. And then I can take my year and fill that in as well. Oops, sorry, I didn't mean to put year in there. I think just 2 is enough because it's getting pretty tall. You can change the height of your visualization if things seem to be scrunched. You could change the size of your circles. From the menu, you could remap your colors, you could change the labeling scheme. You have a lot of different options. But because this example has been getting kind of tall, I'm going to take us into a smaller data set to show some more of the features. So I could also repeat this hierarchical exploration approach to the top baby names by year dataset. And I started doing this as a tree, and it really felt like it was going to be hard to see everything without having to scroll. So for this, I thought maybe we would try a radial layout. So I'm going to show how we might go about doing that inside of raw graphs. So to do this, I'm going to go back up and say reset. I'm going to upload a local data set. I took just the top 5 baby names in the years after 2015. And I'm going to select the circular dendrogram chart type. So to reproduce the graph that we saw earlier, I'm going to start by splitting by ethnicity. Split by gender, then by ethnicity. And we have the beginnings of a snowflake in progress. Then I can add another column, and we've added a ring for all the names. And then I can add another column for the years. And we have this nice little tree in progress. So I'm going to widen it so that things are not so scrunched. I can increase the margin on the right so that we don't run out of space. I'll change this to, say, 130. Maybe it needs to be 200. Now it all fits. And then now I can make use of color as a variable. So I'm going to take the rank and bind that to color. Because these are categories and not really a range, I'm going to change my color scale from sequential to ordinal. I can change my color palette. And if I just decide, well, this yellow is really hard to see, I need to remap that, I could change that to purple, and it updates really quickly. So there's a lot of really polished visualizations that people have made with raw. People have used it directly inside data journalism articles. I don't use it that often for data exploration, but the main thing I hope you'll take away from this raw graph section is that you don't have to necessarily go to code to access some of these visualizations that feel like that you would otherwise have to reach for D3. And if you do know how to code and you'd like to check out the implementation for these graphs, for each one of these things, you can go to the code section and look at the source code for this particular graph on GitHub and adjust it for yourself. So I think that's it for now for the different visualization types. I think now we have to address the elephant in the room, which was how did you shrink these data sets down to a point where they were clean enough to be used in some of these browser-based tools. I have a confession to make. I wrote Python code to clean data for work for over 5 years, and I still clean and filter my data inside spreadsheets sometimes, even though it's not repeatable. And that's because clicking is easier for me than typing. It's a lot faster. It doesn't feel worth it to go out into a separate programming environment. So I think just because somebody is able to code doesn't mean they're going to be throwing code at the problem all of the time. And that's what these next two tools are motivated by. So the first one of these that I want to recommend is called Dataset. It was designed for data journalists, made by a data journalist named Simon. And the nice thing about Dataset is that it can both make SQL for you, or you can write SQL somewhere else and put it into Dataset. And with Dataset, you can effectively make your own data portal by creating a folder full of CSVs, running a command. He's a lot of tutorials on his website. And there's a lot of plugins that will let you explore data from directly inside this environment. So I'm going to show you a quick demo of this. So I've loaded up the restaurant, some of the restaurant data that we saw earlier. And by default, it produced some maps. So this little cluster here is the famous null island, 0, 0 coordinates. So these restaurants probably are not actually here, but it's just geocoded data was missing. And underneath, you can see a big table of all the data that might otherwise be in a CSV. And if you want to actually start trimming down these data sets, and I'm going to show this with the baby names example, you can just kind of point and click your way through it. So I decided I was going to split by the year of birth and maybe the gender. And it's showing me how many rows fit into each of these categories. So let's say if I was just interested in things in 2015, I can click on that, and this column has been filled in for me. Let's say I also want to just look at the male names, and this form has been filled in for me. And if I want to take this SQL query and reuse it somewhere else, I can click View and Edit SQL, and here I have something ready to go to copy and paste. And so the significance of having the SQL query is that, let's say I have to do this filtering operation on this data set for another city. Well, rather than pointing and clicking my way through a spreadsheet again, I could just load up this text file or this SQL query, paste it into the query editor, and I don't have to go through that analysis again. But not everything can be done with SQL. And also, you still end up needing to do some data analysis in another tool to figure out what sorts of filters might be useful as you're exploring this data set. And so to solve that problem, sometimes I also like to use this tool called Mido Sheets. And Mido Sheets is a spreadsheet-like interface which generates Python as you're clicking your way through, specifically pandas code. So I'm going to show you a small example of that. To do this, I wrote 2 lines of Python. I imported pandas and Mido Sheet, and let me go into full screen. I loaded up the same CSV that we were seeing before. And inside Mido, inside my filter column, let's say I wanted to take care of null island, basically. So if I go over to latitude and longitude, I can go over to values and I can see how frequently these null values appear. So there's 581 of them. And I can say, I don't want those anymore. Here we go, filter. Yeah, so I don't want 0 values, and I also don't want empty values. Nope, this is not doing what I, well, okay, small demo effect. So I'll skip this part, but I want to show one other thing that I don't really know how to do inside of SQL, which might be convenient to do inside of Mido. So I knew that I had 2 different date columns. I have inspection dates and I have creation dates. Oh, now I know why. This is the wrong data set. I'm going to import the data set that we were looking at before, which is the raw business licenses. Here we go. So the business licenses data set, we were graphing by license length earlier, but that didn't come inside of the data set. That was something that had to be calculated by comparing the creation date from the expiration date. So to calculate a duration, I might do something like insert a column, and I have to take these 2 columns and convert them from strings into dates. So I'm going to do that. Change my D type to a date time, change this one also to a date time. And the duration is going to be the expiration date minus the creation date. And I now have a bunch of durations to take a look at. So now I'm going to filter by all the durations that failed for some reason, and that's usually because the expiration date didn't exist for some reason. So now I can filter by add a filter and say if it's not empty, and it's removed a bunch of these invalid values for me. Let me change this to duration. And I've kind of glossed over this part, but if we look underneath, all this code has been generated, which is repeating everything that I've been doing in a point and click way. And it's probably not going to be that great for you to watch me clean data for the next couple minutes, but I just want to motivate the idea that if you did want to use a spreadsheet interface to clean your data, if you do it inside a tool like Mido Sheets, it's going to be easier to repeat this analysis later without needing to go through as many manual steps again. And I use these two tools to produce all the slice data that we saw in the earlier examples. So there was actually one tool that I had wanted to show many slides ago, but I wasn't able to because the data set was too large. And I was able to clean up the restaurant inspections using Mido Sheets to a subset that was small enough to be doing analysis inside a web browser. And that's this last tool called Voyager. So I've taken the restaurant inspections, I put them on my clipboard. I'm going to import this data. And Voyager, I would compare it to auto-suggest inside like your favorite text messaging tool. Now, you're not going to write your whole message to somebody using auto-suggest, but something that's nice about a graph recommendation tool is that if you're not sure where to start, it offers some starter graphs for you to look at. So here I can browse basic counts for all of the different columns that were available inside restaurant inspections. And if I see something that stands out to me, say the distribution of scores, I can click it, it'll promote it to my main workspace, and then it'll start showing me some more variations of that graph that I started with. So I can have my score, then I can learn that, well, maybe it would be nice to split by the type of inspection. So I can pivot by that as well. And I can just kind of repeat this process and explore a number of different graphs. And when you're done with this, if you'd like to take this and build on our low-code theme, you can go to Bookmarks, Export, and then it produces in this case, it actually inlined the whole table. You might want to remove that part. But at the very bottom, you have a VegaLite definition that you can copy and paste into another graphing tool and make use of the recommendations. So to wrap things up, I've taken a number of the graphs that we've seen throughout the course of this demo and arranged them together inside of FigJam. So here's how my process looked like as I was putting together this presentation. I looked at my data set, I read the data dictionary, I did a lot of cleaning and exploring, and I made notes of all the data quirks that I noticed and the data transformations that I needed to clean up the data set. And then I drew out all the different branching paths that I took as I was exploring this licenses data. And I think we have time to maybe look at just one of these patterns. So one of these things was, I was looking at the creation dates and I noticed that people were filling these things out Monday through Thursday and nothing was happening on Friday and Saturday. It's pretty balanced, but a lot of things were expiring on Monday. And I wanted to understand maybe if there were some other columns that would help me to break this pattern down a little bit further. So I had two ways of going about that. One was splitting things out by industry instead. So I looked at one day at a time and I noticed that secondhand dealers were expiring on Sunday, then home improvement was expiring on Monday. I was doing this manually, like each one of these is a single graph. But then I remembered I had the facet operator to work with. So then I went into my little built-in Vega Editor. I added this little facet block, and I just started going through a couple different graphs to see that things are expiring in a irregular way. Each one of these columns look a little bit different, but licenses are created in a pretty balanced way across all the weekdays with a drop-off on the weekends. I guess people aren't working or filing applications on the weekend. Then I thought, well, maybe I might repeat this analysis for Manhattan. Maybe I should be looking at location instead of just looking at day of week. So I said I should backtrack to the last time when I decided I was going to split by date. Here I was splitting by other date fields. So here I was splitting by month. Here I was splitting by year. I decided this wasn't going anywhere. So I backtracked through my tree and I said, all right, here I grouped by time. Why don't I try two different ways of grouping by space instead? So I kept the result of my Sandance-based analysis here, and I used the highlighter to select blocks that I thought were interesting. I saved my Kepler graphs here, where I took some of the time traveling screenshots that we saw previously to see patterns by industry and supplemented what seemed to be jumping at me from the map with some actual bar plots, because it's easier to actually count how many items there are in a bar plot than by just looking at a map. And I also kept some of the Voyager graphs that came from the restaurant inspection, where I went through that same process as we did for the businesses, except I was using a different tool. I went through that pretty quickly, but this wasn't so much with the goal of having you repeat this particular analysis, but just to give you some ideas for what it might look like to stitch these different apps together. So to close, I think it's very helpful to use a infinite canvas to draw the tree of your analysis. If you used a Vega-based tool that produces VegaLite definitions, whatever tool you start in your analysis in, you don't have to end your analysis there. You get something that you can carry with you to other places. And it gives you a lot of flexibility. I acknowledge that Vega won't do everything, so you might go to things like Kepler or raw graphs if you need to produce a tree. And lastly, for the data cleaning step, there are a lot of low-code options out there, including the ones I mentioned today, and also many more that were also in Open Data Week, like OpenRefine, but we didn't have time for. So I just made a list of all the tools in case you want to look them up later. I hope you'll try some of the tools that I shared today and try organizing your map in an infinite canvas as well. Having visualization building blocks has given me more lenses with which to see data, public or otherwise. Who knows if there's a gorilla or a dinosaur in your favorite data set? I'm hopeful that with enough eyes on the problem through low-code tools that we'll be able to find them together. And the bigger uncertainty lies in how that low-code tool will end up shaping how we approach problems in the future, and I'm very excited for that. So thank you for your attention. I'm happy to take any questions that you may have now, or through email or Twitter in the future if you prefer to write. So I know we're a little bit over time, but yeah, I'll stick around as long as people have questions. The slides are not available yet, but I will email them to everybody who RSVP'd. I'm going to stop sharing so that I can see people's faces, because I haven't been able to see anybody this whole time. So Vicky has a question about protecting proprietary company data. Are these tools retaining whether they're uploaded? Okay. This is a great question. This for me is a limitation in what tools I can use as well. So everything that I showed, because it's open source, can be self-hosted, meaning that if data tracking is an issue, you could deploy a version of this code and run it locally in such a way that nothing is being sent remotely. Also, because all these tools are running in the browser and they don't have a server-based component, if you need to have full data ownership, you should be able to use these things with proprietary company data without a problem. This for me was one exception to this is with Figma and FigJam. That one is remote, but everything else is self-hostable. Thank you for the question. There was a question about where Sandance can be run towards the middle. Sandance can be run on the web where it may be tracking you. They say that they're not, but they might be. But you can also run it locally as a VS Code extension. Visual Studio Code is a popular code editor, and that version runs completely offline. Tay asked, do you actively maintain trees for every analysis or only when you're prepping for presentations? I would say that in practice, when I'm making value driver trees or doing a data analysis, I use index cards and I move them around on a table in front of me. And sometimes I'll use yarn or paper just because it's faster for me to think that way. The really hard thing with these trees when you do this in practice is that your branches end up crossing or things are very messy, and it can be slow to deal with this with a mouse or a keyboard if you're not very comfortable in these tools yet. So I usually end up starting my tree in the physical world, and then when I'm ready to share or discuss it with people, I will translate it into a Figma or FigJam form. I don't do it every single time, but I think it's a habit that I try to practice more. What happens for me a lot of the time if I'm doing things in a notebook is that everything just kind of gets flattened up into a line, and I need to turn it back into a tree afterwards. And I feel like if I started making trees earlier in the process, there would be less untangling to do. So using trees, to be honest, is not something I do all of the time, but it's something that I would like to do more of the time. And I think it's useful in the thinking stage and not just in the presentation stage. I actually think for presentations that using a line is going to be the easiest way for people to follow. But the tree is what you would use when you're actually trying to solve the problem and figuring out how to flatten your analysis into something that people can understand. Thank you for the question. Cool. And then I guess I'll take one more question before we wrap the recording. Thank you, Andrew, for sticking around for this. Jenny said, as a UX designer, it was great to see how you explored various ways to make data viz analysis more iterative and collaborative using FigJam, which is similar to design process, which has a lot of iterations and reviews. I'm curious about how this has improved your collaboration with other people in your workflow. I thank you for this question. So I would say that in the previous versions of this tree before we had something like the GraphPad plugin, when I collaborated with other stakeholders, they would be looking at a screenshot of a graph, but be unable to fiddle with things that they could describe. They might say, I could filter this data, or what if we used a different color palette? Could you do that? And then they wait a day or longer if I'm doing other things, and then they see the result, and you have this very long feedback loop. It does take a little bit of time to become familiar with VegaLite, but when you have more people than just your engineers or your data scientists capable with fiddling with graph settings, they're able to make these changes as soon as they think them. They can refilter, they can change the color palette, they can change the axis. And I can't quantify what the impact of shortening that feedback loop is, but my hope is that it's allowing us to iterate more quickly and ultimately build better things because they don't need to switch to another tool or wait for another team to be able to adjust the graph themselves.
That's amazing. I'd love to try it by myself. Thanks, Cameron.
Cool. Great. So I think this is all of the questions that I see in the Zoom for now. I think we can probably wrap the session, but again, I will share the slides via email and open to any questions that people may have in the future.